Most of your questions in the unit will involve calculating pH of singular acids or bases, but on occasion you're going to see a question involving calculating the pH of a mixture. Nice thing is these will only involve strong acids and strong bases. So in this example, we have nitric acid, calcium hydroxide, strong acid, strong base, and we're trying to find the resulting pH. When you are getting that resulting pH, it's the pH after the reaction has occurred. Okay? If I want to know the pH of the initial substances, I just would ask for the initial substances. This is the pH of the resulting mixture after they've partially neutralized each other. So, step one in any of these calculations is to figure out how many moles of hydroxide and hydronium. Note that that's not the whole compound I'm really concerned with. I just need to know the OH part. Okay, and I need to know the hydronium part out of the acid. Step two, calculate the excess moles. So that's just, for instance, if I had 2 moles of base and 1 mole of acid, well, that means I have 1 mole left over of my base, which would be my excess. Calculate the excess concentration. Refers to calculating the concentration of leftover either OH or H3O. And you always divide that by the total volume of the solution, and then you solve for whatever you have to. So, first thing, we said, step one, I want to calculate the number of moles of hydronium and the number of moles of hydroxide. Well, with your strong acids, they're always going to be 1 to 1. So those are a little more straightforward. So I have 5 mils at a concentration of 0.10 moles per liter. And this is hydronium. Liters cancel out. That's going to be 0.50 millimoles of hydronium. Okay, do the same thing for hydroxide. And this is really where the only mistakes come in with these. Calcium hydroxide is CaOH2. So the concentration of this solution of calcium hydroxide is 0.20. Well, there are 2 OHs in each calcium hydroxide, which means the concentration of OH must be double. So I have 10 mils of the calcium hydroxide, but the concentration of OH is going to be 0.40 moles per liter. Okay, please watch that. That is the one trick when you're dealing with strong acids and strong bases, is with strong bases only, you're going to see that mole ratio involving more than 1 OH at times. Okay, so then that works out to be 4 millimoles of hydroxide. Okay, that's step one. So it's pretty clear which one is excess. We have more OH. So to find the moles of excess, all I do is I subtract the big one minus the little one. 5 millimoles of OH, subtract 0.5 of hydronium. So that's going to leave me with 3.5 millimoles of hydroxide left over. Please be sure to label your excess as either OH or hydronium, otherwise it'll lead you to mistakes down the road. Next step, I'm going to find the concentration of my excess. Concentration is in moles per liter. So I have 3.5 millimoles left over of hydroxide. I'm going to divide that by my total volume. It's the entire solution, and I have 15.00 milliliters of total solution. Quickly calculate that, one moment. That equals 0.23 moles per liter of hydroxide. Again, be careful. Make sure you identify that as OH. And then our final step, now sometimes we might be done at this point, But once you have that, you're either going to solve for H3O on top of that, or leave it as OH, or solve for POH or pH. In this case, we wanted to solve for pH. So pH equals negative log of hydronium, but we don't have hydronium. So at this point, I would have a choice. I could either convert my hydroxide into POH and then subtract from 14, or I could use Kw to solve for hydronium and then use a pH. Either or, doesn't matter. So let's, as an aside here, we'll go Kw equals 1.0 times then negative 14 divided by 0.23. Sorry, that's not Kw, that's going to be H3O. So then we solve for that, and that result will go into my log formula.